Hi everybody, today we are starting Module 4 lessons. Module 4 lesson sections are section 4.1 through 4.6. So I'm going to post videos for each section. So today we're going to cover section 4.1, which is inverse functions. So the first one, we are given a set and we are going to identify if the function is a one-to-one function. So in order to check if a function is a one-to-one function, if any of the y repeats, then it's not one-to-one. Okay, so determine So we already learned about function. If any of the x repeats, then it's not a function. But if it has to be a one-to-one function, the x cannot be repeated as well as the y cannot be repeated. That's when it's called the one-to-one function. So the first example, I have the set of ordered pairs. I have 4 sets of ordered pairs here. So we have to check if it is a one-to-one function. So in order to do that, first we have to check if it is a function. Function means if x repeats, then it's not a function. However, each x is unique here. So yes, it is a function. Next, I have to check if it is one-to-one. How do I check if it's one-to-one? You have to see if any of the y repeats. So I have 1, 2, 3, and 1. So if you notice that 1 is repeated here, so it's not one-to-one. However, it's a function, but it's not one-to-one. The next example. So I'm going to draw the mappings here. All the problems I solve are from the handouts I posted on Canvas. So you can also refer the problems. So I'm just I'm drawing the map that is given on Canvas. And then if you see, none of the x repeats. So first we are checking if it is a function. None of the x repeats, so it is a function. And see if any of the y repeats. It's not, so it's a one-to-one. Okay, so it is a one-to-one function. So in order to find, in order to find if a graph is a one-to-one function, so we have to check the horizontal line test. So a function y equals f of x is one-to-one function. if no horizontal line intersects the graph in more than one place. So remember, for function, it cannot intersect more than, the vertical line cannot intersect more than one place. So here, so the graph, I'm just graphing whatever is given. These are the points given. So first you have, let's say if it is, just draw a horizontal line. None of them are, it's supposed to be a little bit closer here. And this one here and this one here. And the point does not meet more than once. So this is this problem number 3. It is a one-to-one function. Let's show you the other one. So these are the graph given. This is the graph. And if you look at the graph, this is the x-axis, y-axis. If I draw a horizontal line, it's meeting the graph more than one place. So obviously it's not a one-to-one function. So the next one, number 5, this next example. This is the graph given. Again, when you draw the horizontal line, it's meeting exactly only once. So it is a one-to-one function. So the next objective, we are going to define inverse functions, which is the main title of this section. So I'm going to define what inverse functions mean. So the inverse functions, so let f be a one-to-one function. It's already given. It is a one-to-one function. Then G is the inverse of f if the following conditions are true. So there are two conditions. Number 1, we have to prove f composite G. We have learned about the composition of two functions earlier. If this is true for all x in the domain of G. And the second condition is the other way, which is G composition f of x has to be x, where for all x in the domain of f. Okay. So for function f of x, the inverse is returned given by the symbol. Inverse is f inverse of x. We read that f inverse of x. So We are going to next, I'm going to show you example of how to find the inverse of any function. So first one, we have to determine if the given two functions are inverses. So let's see. So first example is we are given f of x 3x plus 6 and g of x is 1/3 x minus 2. So all we need to do is we have to check if the two conditions are true. The first condition is f composition. We are doing the composition of g of x by the definition of composition. It's going to be f of g of x. What that means is we have to plug in whole g of x into f of x. So what we are going to do, f of, plug in the whole g of x. G of x is 1/3 x minus 2. Okay, now what is f? Now I'm going to substitute this whole thing into f, that is we're going to substitute this x. So put the 3 for the x. I'm going to substitute 1/3 x minus 2. Now we have to get x. If we get x, and I have to check the other one as well. So distribute the 3. So we get 3 over 3x minus 3 times 2 is 6, negative 6, and plus 6. These two get cancelled. 3 over 3 is 1. So we are getting x in the first one. Next, I have to do the g composition f of x, which is we are going to plug in the whole f into g. What is f? F is 3x plus 6. So we're going to substitute this whole 3x plus 6 for this x, which is going to be, so we write the 1/3. We don't write the x. For the x, we are going to plug in 3x plus 6. Now, next we're going to distribute. So it's going to be 3 over 3x plus 6 over 3 minus 2. 3 over 3 is x. 6 over 3 cancel out. So we are getting 6. So for both, we are getting x. So these two functions are inverses. So f and g are inverses. Okay. So next example, we have to check whether these are inverses. So I have we are given f of x equals x plus 1 over 5 and g of x equals 5x plus 1. So again, we are going to do the same thing. So first we are going to check f composition g of x. So by definition, f composition g of x is f of g of x. So we're going to plug in the whole g into f. So what is g? G is 5x plus 1. So now go to f, substitute all the x in f by 5x plus 1. So I'm going to put 5x plus 1 for x. And then again I have 1 all over 5. So I plug this 5x plus 1 for this x here. That's what I'm doing. Okay. So what I'm getting 5x plus 2 over 5, which is not, if I write this one down, simplify, I'm getting x plus 2, which is not x. I just want x. So once one of them fails, we don't have to go to the next step. So the answer is F and no, they are not inverses. Okay. You don't have to check both. So the next objective, we are going to find the actual inverse. We are given only one function. We have to find the actual inverse. So these are the steps to find the inverse of a function. How to find the inverse? There are 4 steps we have to follow. Step 1, we have to replace f of x by y. Step 2, interchange x and y. Step 3, solve for y. Step 4, replace y by f inverse of x. So I'm going to show you the next example, how to find the inverse of any function. Okay, so the previous objective, we were given 2 functions and we were checking if those 2 functions are inverses of each other. So one example we found they are inverse, the other one they are not inverses. So the next objective, we are going to be given only one function. We have to find the actual inverse of the function. So find the inverse. So number 10. So let's do f of x equals 2 plus 1/2 x. So we're going to follow these 4 steps. So step 1, replace f of x by y. So that is step number 1. So this becomes y equals 2 plus 1/2 x. Step number 2. Interchange x and y. So we're going to put the x as y, y as x. So it's going to be x equals 2 plus 1/2 y. So we switched x and y. Step 3, from this one, we are going to solve for y. This, that means we have to get the y by itself. So I'm going to show the steps here. So we have x equals 2 plus 1/2 y. I have to get the y by itself. So first step, we are going to move the 2. So subtract 2 both sides. So we get x minus 2 equal to one-half y. So now I have to move the 2. I have to get the y by itself. So how do I get the y by itself? We have to multiply both sides by 2. So we can get rid of this 2. So 2 times and then 2 times. You have to put bracket here because we have 2 terms, and then distribute the 2. So we get 2x minus 4 equal to y. So we got the y by itself. So now step number 4, replace y by f inverse of x. that is our F inverse is, we have got the F inverse. So the F inverse of x is 2x minus 4, which is our final answer. This is the inverse of the original function f. So I'm going to show you another example for finding the inverse. So we are given f of x equals 3x over x plus 1. So we're going to go by 4 steps. Step 1, replace f of x by y. I'm not going to write it down. Just I'm going to switch. Replace the f of x by y. Step 2, interchange x and y. So it's going to be x equals 3y over y plus 1. So now step 3, we have to solve for y. That means we have to get the y by itself. In order to do that, this is irrational expressions. We learn how to solve the rational functions, equations. So I'm going to write down, let me write down the equation again. I can put 1 in the denominator. Now for these two rational functions, we can do the cross multiplications. So we get x times y plus 1 equal to 3y. Now distribute the x. However, step number 3, we have to solve for y. So we have to get all the y by itself. So we have 2 y's in this equation. So I'm going to move the y to the other side. So we get x equals 3y minus xy. Now factor, we are solving for y, so factor, we have y as the common factor here. Let's take the y out. So we get 3 minus x. Now get the y by itself. How do I get the y by itself? Divide both sides by 3 minus x. So I can get the y by itself. So I got y equals x over 3 minus x. In step 4, we are going to replace the y by f inverse of x. So this is our inverse, equal to x over 3 minus x. So you can check your solution by doing the composition of two functions to make sure you got the correct answer. And number 12. Again, it's given, we have to find the inverse for the function x squared plus 3 for x is greater than or equal to 0. So again, do the steps. So now I'm not even going to write the steps, just going to do that. So we're going to replace the f of x by xy and replace the y, switch the y and the x or interchange y and x. So this is what we get. Now I have to get the y by itself. So solve for y. So we get y squared equals x minus 3. I have to get the y by itself. So to do that, I have to take square root both sides. So it's plus or minus square root of x minus 3 So y is square root of x minus 3. I'm ignoring negative because it says x has to be greater than or equal to 0. So finally replace the y by f inverse of x. So f inverse of x is square root of x minus 3. So this is final. And the last question in this notes, we are given a graph and then we have to graph the inverse function. So the original graph is given, we have to graph the inverse function. Okay. So the graph is given like this. So we have to graph the original, the inverse function. So now to identify, to graph the inverse function, first identify all the points. So this is the function given 1, 4. The next one is -1, 2, -3, 1. And the last point is -4, -2. So it's easy to graph the inverse function. All we have to do is interchange x and y. That's all we have to do here. So these are the points I had from the graph. So this one is going to go to switch the x and the y. And 2, -1. 1, -3. -2, -4. Now we are going to plot those points. So 4, 1 is going to be right here. And then 2, -1 is right here. And 1, -3 is right here. And -2, -4 is right here. So it goes like this. Okay. So this is the red one, this is the inverse function. And that's the end of section 4.1. So I will be posting 4.2 soon. Until then, bye.